welcome you all for this case study discussion on the topic oscillator instability. So you are going to discuss about the oscillator and what are the reasons for instability creation in the oscillator circuit and how we are going to give a solution for this challenges. We start one by one with the problem statement and then give you challenges and then solutions. So mainly oscillators are used in various applications like communication system and embedded systems and also signal generators. So for these application we need a very stable oscillator circuit which is used for starting from low frequency to medium frequency and high frequency. For these ranges we need to design a stable oscillator circuit. So discuss the topics one by one.
Problem statement. A laboratory experiment using an RC Phase-Shift Oscillator using a BJT amplifier with a feedback amplifier for three RC section instead of for a constant unstable oscillation. Instead of generating an sinusoidal signal, the circuit below destroy the waveform amplitude fluctuation, sometimes no or oscillation at all.
The theoretical analysis of this case study is the RC Phase-Shift Oscillator, which generates oscillations which are based on the Gaussian criterion, which requires the loop gain to be 1 and total phase shift to be 360 degrees. In this circuit, the amplifier provides 190 degree of phase shift and another RC feedback network provides another 180 degrees. The sustained oscillations which will be if the amplifier gain at least 29 and frequency of oscillations to be 1 over 2 pi RC root 6. Instability occurs when these conditions are not properly met. If the gain is less than 29, the oscillations will be diode. If the gain much higher, clipping will be appear. Moreover, resistor and capacitor tolerances and variations in transistors due to temperature also affect the stability.
The next one is proposed transistor tolerance, and the first one is stabilized amplifiers gain. The amplifier gain control the temperature of the design, and the next one is it may be in a good quality or in a good oscillator, and the next one is improve component accuracy. Use precautions the resistor and capacitance of the 1% of tolerance to ensure the predictable of frequency and loop gain. The next one is temperature composition. It helps users to select components with low temperature frequency and with the and it is used to use the negative feedback to reduce the frequency and the loop gain. And the last one is alternative design. It uses the op amplifier like RC oscillator, like Wayne bridge oscillator, that uses it may be better good control gain and uses as a unlinear element.
Expected outcomes are stable output. The oscillator will give a smooth and sine wave without breaking or something. And constant stability. Accurate frequency. The output frequency will remain close to the calculated value and less distortion since the gain is controlled. And reliable operation. The circuit works properly without the temperature.
So I just want to conclude this case study. The conclusion is this theoretical describes the oscillator instability is governed by the Barkhausen criterion. Both undergain and overgain affects the instability, while temperature and pressure affects the component. The control and the pressure are the key components which is reliable on oscillator instability.
So thank you for discussing your solutions for oscillator instability. So we can use automatic gain control methods to stabilize the oscillator output, because oscillator output depends on the various conditions like what is the feedback network used in the oscillator circuit, like RC circuit or LC circuit, or we can you go for crystal oscillators like that, or op-amp based oscillators we can use for various voltage controlled oscillators, and also other oscillators are crystal based oscillators. So these are the various oscillators to get the stable output. So we can also use FET based circuit, JFET based circuit to give you a stable operation in the oscillator circuit. So these are the various methods. So from this we can use the better efficient circuit for the communication systems or embedded systems or signal generators for RF circuit. So these are the solutions we are giving for the chosen case study. So thank you for discussing your ideas.